To justify tolling large trucks, advocates often cite an obscure statistic from a 1979 General Accounting Office study, which states that a single tractor-trailer has the same impact on an interstate highway as at least 9,600 automobiles. The origin of this myth dates back to 1960, with the conclusion of the highly regarded road test. This test was designed to study the performance of pavement structures of known thickness under moving loads of known magnitude and frequency. To do so, the engineers deliberately underdesigned a majority of the pavement sections in order to achieve pavement failure during the test, while the remaining few sections, built according to the modern standards of the day, withstood hundreds of thousands of axle loads. The test demonstrated a geometric relationship between axle loads and pavement effects, so that even a small increase in axle loads could have a large effect on pavement wear. On the other hand, the data also determined that a small increase in pavement strength of thickness would accommodate a large increase in axle loading, which researchers rarely mention. The intent of the study was to help engineers determine load-related pavement requirements based on expected loadings over the life of a pavement. The data from the road test helped to create a standard value for axle weights called equivalent single axle loads, or ESLs. While this standard does show that a single tractor-trailer has the same impact as 9,600 passenger cars, the issue is not that simple, as there are several other factors to consider other than ESL equivalency. First, we must consider the two types of pavement, flexible or rigid. Modern designs utilize flexible pavement, which lowers the ratio to approximately 800 to 1,000 cars per single truck. Moreover, if engineers design the roadway properly, considering both the depth and type of concrete, the pavement will be more durable and extend the life of the highway. The Transportation Research Board has said that when a highway is properly designed, it will not be damaged by the traffic it's designed to support. This is an important point because there are prevalent misconceptions that trucks damage pavements more than passenger cars. This is only true when 1. The pavements are under-designed for the amount of truck traffic that is actually using them. 2. Trucks, through overloading generally, are imposing heavier axle loads than anticipated. Or 3. Other factors not properly evaluated in design have affected the ability of pavements to support traffic. Thus, the pavement damage is not due simply to heavy trucks, but because the state or federal builders did not design the highways correctly. The reason for the excessive damage is more likely that the construction companies utilize less concrete and less flexible concrete slabs than the infrastructure required.